So I have a lot going on in this cell here, but the idea is to try to create something similar to this decision map here. So I want to simulate that, and to do so, I'm using this np.meshGrid, which will essentially pass a lot of XY arguments into our model once it's been fit and allow us to build this map out. And so there we also need a Y value, which would be the predicted value from our XX and our YY, which again comes from this mesh grid and NumPy. We're going to begin using a linear kernel for our support vector classifier. And here you can see that our linear boundary does not do very well for this set. And that's not surprising because this data is not linearly separable without a kernel. And this is where adjusting this RBF, and let's set a gamma value there, which helps us to really determine how much we're going to weigh the local points versus the further away or more global points. And this is the benefit of using a kernel, but also the benefit of having a way to design your data set. And so if we were to reset this, and so we're going to just draw something that's fairly straightforward, we would expect this to be fairly separable using a linear kernel. If we update our XY, if we look at the supervised machine learning, I'm going to keep my radial basis function. We can see it does an interesting job trying to fit this data. We do have these decision bounds. Now let's switch back to our linear function and see how that does. And in this is a much simpler projection of the data. We don't expect these lines to be that wiggly unless you have more data to support that. But I would rather see these linear decision boundaries between my four classes. And then if we had a more sophisticated data structure, then we might explore different kernels. In the case, I'll see you in the next video. Peace.